So this video is going to be kind of like a refresher or review over the last two lectures. I know some of you had some questions about these last two topics, and I know it's tough learning it without me there personally. So I'm going to try to go for this a little bit slowly and talk about basically E and ln derivatives, and also talk about max and min. So first of all, this is a question that you see on your screen that a lot of you had questions about. So I want to go over how they did it in the key that made it a little bit easier than what some of you have been doing. First of all, a lot of you saw this as a chain rule. Some of you may not have noticed that this is, kind of like all inside of ln. So if I had to do the chain rule, I basically would have to do the derivative of the outside, which is ln, times the derivative of the next inside function, which is 5, times the derivative of the next inside function is this one. That is something that you can do. That is the hard way. If you do it that way, you'll still get the correct answer. The next easiest way you can do this is, if you remember your log rules, you should remember that every time you have a log and something exponent, again, this is review, that means the exact same thing as making that exponent the coefficient. Or in other words, just putting it out in front. So putting the 5 out in front means the exact same thing. If I do it this way, remember, I could leave the 5 alone, and I could just take the derivative of ln parentheses negative 4x to the fourth over x to the third minus 3. So that's a slightly easier way. Okay, but the easiest way to do this, if I erase this all, is sort of to combine the two and use your log rules. Especially for the AP exam, anytime that you encounter a problem and it takes too long or it's so difficult, it's probably you're doing something wrong. They never intentionally give you a very, very, very long problem or a problem that takes a whole page to solve. There's probably an easier way to do that. And the AP, as long as I've known, the AP never gives that difficult a problem. Okay, so first of all, here is the easiest way you can do this. First of all, like I did last time, I'm going to kick this 5 out in front. And again, this means the exact same thing. And another thing we can do, if you remember your log rules, and remember, that's the whole reason why we started the whole year off remembering our log rules and trig and stuff like that, because it'll make things a lot easier for you. On the inside of this, on the inside of these parentheses, you'll notice that I have a fraction, and I have a fraction inside ln. If you remember, I could actually make this into 2 ln's. I'll keep the 5 on the outside, and this means the exact same thing as ln of negative 4x to the fourth minus ln of x to the third minus 3. So I don't know if you remember your log rules. We did talk about it in the first couple weeks of the school year, but ln of a fraction means the same thing as ln of the numerator minus ln of the denominator. Okay, and then from here it's actually very simple. What I'll do, and I won't solve out the whole way, but I'll leave the 5 out in front. This is going to be 2 chain rules. The derivative of the outside function, the derivative of ln, is going to be 1 over negative 4x to the fourth times the derivative of the inside, which is negative 16x to the third. So that is the derivative of the first ln. The second ln, same thing, 1 over x to the third minus 3 times 3x squared. And if you look at the key, all they do is they simplify this even further. So you may notice that on here I have 3 x's on top, that could cancel with 3 on the bottom, or here on the right, well, I guess nothing on the right cancels out. But that's how they solve it. So if you looked in the key, if I scroll down to the key, that's how they got this part. I know some of you that did your videos are like, how the heck did they get that part? And it says rules of logarithms used. That's how they did it. They made it simpler for themselves. So just as a rule of thumb, remember, for these types of problems, if it's too difficult, takes too long, you're doing too much work, you're probably doing something wrong, or there's probably an easier way to solve it. All right. What I want to do is continue from yesterday's lecture. Yesterday's lecture was about max and min. Because of time, I kind of stopped after one example, but I'm going to do 2 more examples for you, see if this makes this a little bit easier for you. Say, for example, they give me a function that looks like this. And I want to know what is the max and min of this function, or the relative max and mins, the local max and mins. Where is this function? Where are the points where it's the lowest and the highest relative to the rest of the function? Well, if you remember, to do so, I need to take the derivative. And if I take the derivative, you'll notice that these are square root problems. So it's like this one is very similar to, or it means the exact same thing as x to the 4 thirds. and this one means the same thing as, this thing means x to the 4/3. This one on the right means the exact same thing as x to the 1/3. Okay. So if I want to take the derivative of the first one will be 4/3 x to the negative 1/3 plus, sorry, I forgot my x here, plus, again, taking the derivative, it'll be another 4/3 x to negative 2/3. Okay. Oh, sorry. Let's do it again. This whole function means the exact same thing as x to the 4/3 plus 4x to the 1/3. Now when I take the derivative, it's going to be 4/3 x to the 1/3, doing the power rule, plus 4/3, 4 times 1/3, x to the negative 2/3. And again, because I'm trying to find max and min, I'm going to set this equal to 0. And by setting this equal to 0, I'm going to find the critical numbers. And again, the critical numbers is defined as the number at which the max or min have to be at. Now, this might look confusing. The next step we always did was factoring, but I don't think you've ever done factoring with these fractions. So let me show you how to do that. Before, if I do the side notes, and again, you don't have to copy this down, but say for example you had a 3x to the 3rd plus 2x. Let's make it easier, or not easier, but a little bit different. 3x to the 3rd plus 6x, and I say, hey, factor this. You probably in your head do factor out a 3x because they both have a 3 and they both have an x, and on the inside you get x squared and you get a plus 2. And some people may be asking you, say for example someone who didn't know math, they say, how'd you get this x to the 2? And you tell them you took an x and you subtracted it from x to the 3rd, that's how you got x squared. If you keep that in your mind, understand how that works, you'll understand how I'm going to factor this one. And again, if you don't understand, I'll explain more when I see you. But in this particular problem, I think you all understand that they both have a 4/3, and they both actually have an x to the negative 2/3. Think of negative 2/3 as the smallest number between these exponents, so I could take out an x to the negative 2/3. Okay. When I factor out an x to the negative 2/3, when I subtract a 1/3 minus a minus 2/3, that becomes 3/3, or just x. Okay. And if you don't believe me, try it yourself. Try distributing, like doing the reverse of factoring. You're going to get x to the 1/3. Okay. And then the second piece, that's the same thing, so it just becomes x plus 1, like so. And again, I understand that this might be confusing to you, but if you understand the concept where I subtracted, all I did was take out a negative 2/3 and I subtracted 1 minus a minus 2/3, which gave me 3/3, or just 1. And again, if you don't believe me, I mean, maybe you probably believe me, but if you don't want to see it for yourself, try multiplying this, distributing back out. If you distribute it, you should get the exact same problem, or the exact same function that we had to begin with, and you'll get that. Now, we have two things that multiply to give me 0. Again, I'm going to take the first one and set it equal to 0. For this to equal 0, x has to equal 0. And the second piece, x has to be negative 1. Okay, my two critical numbers, or the coordinates where I have a max or min, are 0 and negative 1. So the next step I did was I put a number line, putting it in order, negative 1 and 0. And again, I have 3 intervals. I have one interval here, interval number 2, and here's interval number 3. I just don't know, is it increasing or decreasing at these intervals? So what I did is I tested some numbers. Again, the easiest number to test here is going to be negative 2. Here's going to be negative half, and here's going to be 1. Okay, I'm going to test some numbers to see what the sign is at those intervals. Now, if you remember, I took those numbers and I plugged it back into the equation. And some of you are saying, like, man, this is going to be so confusing because what is, if I plug in negative 2 into here, what does this become? So it might be easier for you to rewrite this as, still have 4/3. But the bottom is going to be cube root of x squared. So remember, x to the negative 2/3 means the exact same thing as cube root of x squared, but on the bottom. Okay. So now that I do that, this should be a lot easier for you. Okay. So I'm gonna use my green pen. If I plug negative 2 into this first piece, that is negative 2 squared, which is 4. You don't need to know what this all is, but you'll know that your sign is going to be positive. So this is going to be positive. If I plug negative 2 into my second piece, negative 2 plus 1 is negative. And a positive times a negative, this whole interval is negative. Negative half, if I plug in negative half into these two, Negative half, same thing. I don't know what this is, so if I plug in negative half here, I'm going to get a positive number, because negative half squared, which means this whole thing is positive, and positive divided by positive is a positive, so this is still positive. If I plug in a negative half into the second part, I'm going to get also a positive, so this whole interval is positive. And the last thing is 1. If I plug in 1 here, I'm going to get a positive again. And if I plug in 1 here, I also get a positive. This whole thing is positive as well. Okay. So how do I solve this? Again, I have to have a max or min at -1 or 0. At -1, because I go from negative to then a positive, I have a min here. This one is new to you all. I go positive to positive. So what does that look like? It looks like I have a slope of positive. I kind of stop for a second, and then I go positive again. This means I don't have a max or a min. So this tells me my critical points are -1 and 0. Okay. This tells me I'm decreasing from -infinity to -1, and I'm increasing from -1 on to infinity. And the last thing is that I have a min at x equals -1. So again, just repeating the stuff from last lecture. And the last example I want to give you, I don't think it's as difficult as that last one, but let's look at this function. And I say I want to know where is the max and mins of this problem. Again, the very first step you're going to do is take the derivative. The derivative, this one is a chain rule, so it looks like the derivative of the outside, right? 3 goes in front, I subtract 1, so that's how I get squared, times the derivative of the inside, which is 2. Simplifying this, this becomes 6 2x minus 3 squared. And again, because this is a critical number max-min problem, I will set this equal to 0. You'll see that I have a 6 there. I could divide both sides by 6. So now this just becomes 2x minus 3 squared equals 0. Okay. So after this, after I found this, remember I set this equal to 0, and I found out that x has to be 3 halves for this to be equal to 0. So in this particular problem, different than all the other problems, I only have one critical point. I take that critical point and put it on a number line. If it's easier for you to understand, because some of you don't like fractions, consider 3.5 1.5, which means I have 2 critical points, or I have 2 numbers, or 2 intervals rather, interval 1 and interval 2, and I'm going to test the easiest numbers I know. To the left of 1.5, the easiest number to test is 0, and 1.5, the easiest number to test is 2. So let's test these 2 numbers. In this particular problem, I don't have anything to multiply by, so if I plug in the number, I just see what sign I get. If I take 0 and put it into my, my derivative, I'm going to get 0 minus 3 squared. You should know that 0 minus 3 is -3, and -3 squared is positive. So this becomes positive. Okay. If I plug in 2, I'm going to get 4 minus 3, which is 1, and 1 squared is 1. I get a positive in both intervals. Okay, so hopefully that makes some sense. Yeah. So now, if I had to solve the whole problem, the 3 things again. Number 1, I have a critical point at 1.5. 2, you'll notice I have no negative sign, so I'm increasing everywhere. -infinity to infinity. And the last thing is I don't have a max or a min. Just like the last problem, you see I go from positive to positive. So again, if I had to draw that, I go from a positive slope, I stop for a little bit and go positive again. I don't have a max or a min. So that's where I write no max, no min. So that is how you solve these problems. It's not supposed to be difficult. I know the process is long, but I think you guys will understand this. For the rest of the class, I'll have you try the rest of that worksheet that I gave you yesterday. And again, I'll have you do a video so I can kind of know where you guys are at. So if you have any questions, feel free to message me or put it in the video. I hope you enjoyed the video. So other than that, take care.